on the pink notes, would you please turn your paper over, and we're going to start with example number 1. We're going to come back to that other stuff that we skipped. But in example number 1, this is the same kind of problem we were doing yesterday, where we have a amount of money put into account and it's compounded quarterly. They did not put a little chart on your note paper, so I made a little chart for you. This number right here is the principal amount. It's the number you start with. Here is the interest rate. That has to be divided by 100 because the rate has to be in a decimal form. If it says compounded quarterly, the N is equal to 4 because there's 4 quarters in a year. And then right here it tells us 5 years. You plug that into the calculator. Oh, where did I get the 20? There's no 20 over there. And so this is N times T. It's a little bit easier to get it in your calculator if you go ahead and multiply those together. Divided by 4 raised to the 20th power. And so the amount after 5 years just put it in the calculator, figure it out. Now, before we go on to the next part of this problem, I need to go back. I feel like I didn't do a very good job explaining what the compounded interest thing is. Turns out that remember, you ever heard of pi? It's an irrational number that comes up when you do what kind of shape? Circles. E is an irrational number that comes up when you do these special. And when you compound continuously, instead of using this equation, we will use this second equation. The second equation is the compound continuous equation, sometimes called the PERT equation for obvious reasons, I hope. We still have the same information. By the way, I am on 1B in your notes. Back to your notes, problem 1B. All the information is the same, except instead of using quarterly, we're going to compound continuously. Whenever you see continuously, you use this equation. The P was still $3,000. E, R, T. This is how you put it in your calculator. 3,000 times E raised to the 0.04 times 5 power, and that is how much money? 664.21. It's not a whole lot more than part A, but it's a little bit more, isn't it? If it was your money, you would probably want to have a little bit more money. So you might, if you had a choice, want to use the second method that was in part B. Was there a question about? Okay. Example 2. In example 2, since this says compound quarterly, I'm going to use the first equation. The first equation is for compounding quarterly, or anything else that's not continuous. Okay, so what's the 5,000 in this problem? The 5,000 is the P. Do we know the interest rate? 0.0425. If we're compounding quarterly, that's 4 times a year. And so then this is 4T because it says how long. We don't know the time. But there is one more thing we know in this problem. We want to double our money. If you double 5,000, how much do you get? Because it says so in the problem right there. We're doubling it. And so what I need to do to solve this is I need to isolate this part right here that has the variable in it. So I'm going to divide by the 5,000. Now, to make this a little bit easier to figure out, I'm going to go ahead and put the 1 plus 0.0425 divided by 4 in my calculator and decimalize it. And that is going to be equal to 2. What you do not do at this point is divide by the 1.0106. If you're not going to divide by that, what are you going to do to solve for the t? What's because going back here, the very first step in the problem is to divide by the 5,000, and that's where the 2 came from. Some of you got it right. What we are going to do here is take the log of both sides. We take the log of both sides when the variable is the exponent, and that's why we learned all that stuff about logs to do this kind of problem right here. The reason we take the log is the log has a power rule, so we can use the power rule and bring this out in front. I'm solving for the t, so I am going to divide both sides by the log of 1.0106 to cancel that out. So I am getting my calculator, log of 2 divided by log of 1.0106, 65.7372 is equal to 4t. Now all I have to do is divide by 4. 16.43 years. You take the log of both sides when you are solving for a variable that is in the exponent position. That's when you take the log of both sides. Now, would you look at example 3? In example number 3, when you see the word continuous, you use what is called the PERT equation. P, E is this new special irrational number we learned about. And so in this problem, what is the P equal to? 5,000. I'm not there yet. This number right here is the P. What is the interest rate? This number has to be divided by 100 to change it into a decimal. Do we know how long? But we do know that we're going to triple that $5,000, and if you triple the $5,000, it becomes $15,000. This is almost like the problem we just did, right? So what's the next step? Take the log of both sides. But here's where it's different. Wait. I'm a step ahead of myself. The first step is to divide by the 5,000. And then we're going to take the log of both sides. But when we have an E, we do not take the base 10 log. The calculator has another log in it. The other log in the calculator is called a natural log, and it is base E. So we are going to take the log of both sides, but it's going to be the natural log represented by ln. Do you see the ln on your calculator? The natural log is a log. It's just base E instead of base 10. It has all of the properties of a log, including the power rule. So this would become 0.0. Did I write it down correctly? Yes. And so the power rule says that this is going to come out in front of the log, and that's what I wrote here. Now, here's where taking the natural log gets one step easier. Because what is this equal to? ln, the ln log is right there. E to the first power, what's that equal to? This is equal to 1. Because the base is E and that is E, and E to the first power is equal to E. This is equal to 1. What is 1 times 0.055? 0.055. And then I'm going to divide both sides, 0.055, to cancel that out. Log of 3 divided by 0.055 gives me 19.97 years. So it's the same steps that we did in example 2 and example 3. The difference is when you have an E in the problem, when you take the log, you use the natural log instead. Now, since this natural log is totally new, I would like to do some additional examples with you. So on your homework paper, would you look at problem number 4? That's the one that has the problem stapled together. If you see the word continuous, you use what is sometimes called the PERT equation. In problem number 4, where am I going to put the 6,000? The 6,000 is what? P. R is this number divided by 100. Do we know what the T is equal to? But we have one more word here. What does it mean to triple the money? If I start with 6,000 and I triple it, how much am I going to have? To solve this, I isolate the base first by dividing by 6,000. T is what I'm solving for. T is an exponent, and that means in order to solve for it, I have to take the log of both sides. Since this problem has an E in it, I'm going to take the natural log, ln, not the base 10 log. The natural log still has the power rule, so this comes out in front. This is equal to 1. So this becomes divide by 0.045 to cancel that out, and ln of 3 divided by 0.045 is equal to 2441. That's not good enough. 2441 what? Years. If it is time, you need to tell me whether, most of the time it's talking about years, but there will be some problems that might be hours or minutes. You need to write the words that tell me what that number stands for. It stands for the number of years. Would you please see if you can do the next problem? What are you going to do next? And then you use the power rule. This is equal to 1. 1 times 3 is still 3. So this is ln 1.2 equals r times 3. What do you do last of all? What is the final answer? You're rounding off a little too much. That's not the final answer. What does R stand for? Rate. How do we express rate? As a percent. So we need to do one more step. If it is a rate, we need to change it into a percent. What would that be equal to? Now, I am rounding to 2 decimal places, but it didn't really say how many decimal places. So if you rounded to a different decimal place, that would be acceptable also. Now what? And 5 times 2 is 10. And so what some people have tried to do at this point is take the log of both sides. You take the log of both sides when the variable you're solving for is an exponent. Is the r that we're solving for the exponent? The exponent is 10. In order to solve any farther, I have to get rid of the 10. Do you remember how to do that? You raise it to the reciprocal power to cancel out the exponent of 10. You take your calculator and do 1.5 raised to the 1/10th power. In order to avoid a rounding error, you probably need to use at least 4 decimal places. Now what am I going to do with this 1? I'm going to subtract the 1. What am I going to do with the 2? Multiply by 2, so the R is 0.0823. But rates need to be changed to percent. And so I don't leave the answer like that. It would be 8.23%.